Welcome. A solar eclipse is a rare and wonderful sight, and we all have the opportunity to see one on the 8th of April of this year. This is one of the few solar eclipses that will pass over the entirety of North America, and that means everyone will see at least a partial eclipse of the sun, and a lucky few will be able to see the total eclipse itself. In this presentation we will show why solar eclipses occur and explain what the path of totality is, and show maps of what that path will be this time around, as they are different for each eclipse. You should check the web for conditions and timings in your local area. As an example, we will focus here on the local viewing in the Washington DC metro area, where the eclipse will peak at about 89% and last about 4.5 hours, starting at 12:50 p.m. We will also discuss how best to view the eclipse safely. So how does an eclipse work? The moon orbits Earth and occasionally gets between us and the sun, creating an eclipse. It may come as a surprise to some of you that the apparent size of both the moon and sun vary in our skies. When the moon is larger than the sun, the moon's shadow reaches the surface of the Earth, and then we get a total eclipse of the sun when all three bodies align. When the moon appears smaller than the sun, then the shadow does not quite reach the surface of the Earth, and we get what is called an annular eclipse, like the one we had late last year. Why then don't we get an eclipse every month? The answer lies in the fact that the moon's orbit is not the same plane as the ecliptic, the apparent plane of the sun's path in our skies. The inclination of the moon's orbit is about 5 degrees to the ecliptic. That's 10 times the diameter of the sun. So rarely does the moon's path cross the ecliptic, so the moon, Earth and sun align properly. So an eclipse of any type are rare. Some of you may remember the total eclipse of 2017. On the left is a photograph of the 2017 event. During the totality, you could see the outer atmosphere of the sun, the corona. Notice that the shape of the corona at that time is relatively simple. That is because the sun's activity cycle was approaching solar minimum conditions. So is that what the 2024 eclipse will look like? No. On the right we have an image of the corona taken just a few hours ago, and it's bigger and brighter and more structured than it was 7 years ago. That will make this eclipse more spectacular than the last one. What makes a total solar eclipse so rare? If you waited in one location for an eclipse, then you'd be sitting around on average for 375 years before you saw one. This is also a special eclipse as it's near solar maximum, so that makes it about 5 times rarer. Solar maximum lasts for 2 years, the solar cycle is 11 years, hence 1 in 5 chance. The thing that makes them so hard to see is the weather. Typically only 1 day in 3 has conditions that are favorable in viewing an eclipse. And one thing that can frustrate eclipse hunters is that it gets colder as the eclipse progresses, which can make clouds appear even on a clear day. You need to prepare for an eclipse. First thing you must remember is that you never look at the sun directly, even with sunglasses on. The only type of glasses you can use to look at the sun are what are called solar eclipse glasses, or you use welder's glass number 14. The higher the number, the more blocking there is. You shouldn't go lower than 14. A pinhole camera can be used, and you can see designs of those on the web. And you can also use the shadows under trees. The trees have gaps in the leaves, and they act as pinholes and will project an image of the eclipse on the ground. Telescope and binoculars are not particularly useful unless you have a full aperture solar filter. Remember to dress warmly. It gets cold during an eclipse. You also need sunscreen, broad-brimmed hat and UV-coated sunglasses, because even up until the time and after the eclipse, the sun is still producing a lot of ultraviolet light that can harm your skin and your eyes. Just listen to the crowd reaction as the shadow approaches.
Oh my God! Whoa! Oh, geez. life.
Look at the lights are coming on down there. Oh, look at the lights coming on down the valley. Look, you can see the lights.
Oh my.
This is a view from space when the shadow of the moon passed across North America for the 2017 eclipse. For this eclipse, the path of totality starts in the middle of the Pacific Ocean. It crosses Mexico, enters the US through Texas, travels northeast, exiting North America over the Canadian Maritimes, and ends in the northern Atlantic Ocean. The path is about 140 kilometers wide, but the closer to the middle of the path you are, the better and longer the viewing will be. The maximum duration of the eclipse will be about 4.5 minutes this time around, which is actually a good long eclipse, so it should be quite spectacular. The further you are away from the path of totality, the less of the sun will be covered by the moon. DC is just outside the 90% contour. That means it will get darker, but not completely turn to night as it does during the main phase of the eclipse. This is a simulation of what the eclipse will look like from DC. You can see the moon sliding across in front of the sun. That will be the maximum, and then slide off again as the sun starts to set. If you miss this eclipse, the next good chance to see a total solar eclipse isn't until 2045. That one starts in the eastern Pacific Ocean, comes over in northern California, travels southeast and exits the US via Florida. It then crosses the Caribbean and just kisses the north coast of South America. So what conclusions can we draw from all of this? Your first total eclipse will likely not be your last. This is a very emotional experience, much more emotional than you will imagine. People get hooked on viewing these things and will travel all over the world to see another one. The first priority is to choose a good site to observe the eclipse. Where is it with respect to the line of totality? You want to be on the line of totality if you possibly can be. And also, you want to make sure it's a site where the skies are likely to be clear. Safety is paramount, eye protection in particular. Staring at the sun even during the partial phase of the eclipse is not a good idea. You need eclipse glasses or welder's glass number 14 or a pinhole camera to watch the eclipse when the main phase of the eclipse is not occurring. If you want to try to do photography of the eclipse, that's quite tricky. There's a very rapid fall off intensity from the sun as you go further and further out. So you need something called a radial filter, for example. I would suggest if you want to take photographs of the eclipse, get a good book on how to photograph them. Otherwise, just have a lot of fun because it's a wonderful experience, I can tell you. So thank you for watching, and until next time, goodbye.